Good morning, class. Today we are going to start with type 3. Okay, we finished type 2 theorems. Type 3, we have two theorems in which we are going to prove those theorems using similarity. Okay, so I hope everyone still remembers the concept behind similarity. So today we are going to prove Pythagoras theorem. We have done this earlier once, I remember. So I'll tell you. In a right angled triangle, so when that is written to you in a Pythagoras theorem, please understand that this is what is given to you in the question, that in a right angled triangle, so you already know that there is a right angled triangle. The square of the hypotenuse is equal to the square of the sum of the squares of the other two sides. So you know the idea behind it. H square is equals to p square plus b square. Okay, so what we do first is we first draw our right angled triangle so that it is convenient for us. And generally we would draw our right angle triangle in this manner. Okay, so you have to mark out what is right angle here. Suppose this is A, this is B, and this is C. So this is what is given to you already in the question. So when we write down given, so we write down given is a right angled triangle. Right angled triangle, okay. Right angled at right angled D, okay. Angled at B. So sorry, A. So this is A, right angled at A. So this is what we know already in the question, and we also know what we need to prove from here, right? To prove, you know what is your hypotenuse here, BC square. So we have BC square is equals to perpendicular AC square plus AB square. So this is what is your Pythagoras theorem, and this is what you need to prove at the end. For this we need to do a small bit of construction. So your construction is, before we start with the proof, construction is that we are drawing a perpendicular from A, okay, to BC at D. So we are drawing this perpendicular from here at point D. So since it is a perpendicular, you have to mark it as a perpendicular. Okay, so that would be your construction. What we are saying in construction is from A, a perpendicular is drawn from A. You are drawing a perpendicular is drawn to BC, okay, at D. So from A we are drawing a perpendicular to BC at D. Okay, so this is what we are done with. Okay, what is given, I think, to proof, and construction is understood with, right? So we will move on. I'll quickly erase this. Okay, you'll also have to note all this down. Okay, now for the second part, now we come to the proof, okay, which is very important for you to understand when we start the proof. So like I told you, we are using the concept of similarity to prove this theorem. So we are starting with the proof, and when we are doing this proof, okay, we are going to use similarity. We are going to take two triangles into consideration. Okay, one is the small triangle here which you see, okay, and one is a large triangle which is already ABC, and one is A, C and D. So we'll say in triangle ABC, which is the large triangle, and triangle smaller one ADC, and to prove similarity we are going to use two things which we already know. In triangle ABC, okay, you can see one is 90 degree, that is this angle, okay, that is BAC is 90 degree, and in this triangle also you can see 190 degree. So I'll just mark the 90 degrees. In small triangle this is a 90 degree, in large triangle this is a 90 degree. So we have these angles which are equal to each other. Okay, so angle BAC is equal to angle this one, okay, ADC. Reason, both are 90 degrees. Okay, second angle that you will find is this angle, which is there in the large triangle also, and which is there in the smaller triangle also at the same time. Okay, so you'll find these two triangles there. So the first one is for the large triangle. If you have to name it for the large triangle, you would name it at ACB for the large triangle, angle ACB. And for the smaller triangle, you'll name the same angle as ACD is equal to angle ACD. And what kind of triangles are they called? They're called common angles, because they are common to both the triangles at the same time. So we can say, therefore, triangle ABC is similar to triangle ADC, and the reason being angle. Okay, after this is the main important thing that we need here. After the angles are the triangles are similar to each other, what do we say? We say that if triangles are similar, then angles are equal, which you have already written, and sides are proportional to each other. Therefore, we will write down the proportional sides, which is very, very important now. So first we'll start with the large triangle. Which is the side opposite to 90 degrees, since the angles are equal? Opposite to 90 degree in the large triangle. So this is our 90 degree, and opposite to that is BC. So we'll take BC by the same 90 degree in the small triangle. If you see, then opposite to that is AC. So it is BC by AC. Second is this common angle. Opposite to that here you see is AB. Okay, so you will get AB. And for the same common angle, opposite to that in the small triangle is AD. Okay, now last thing you have to see is which sides you have considered already. Like you have done BC, you have done AB. So you have done AB from the large triangle, you have taken BC from the large triangle. This side is left, that is AC. From the smaller triangle AC, you have already taken AC, you have already taken AD. Okay, from the smaller triangle. What you have not taken at all is, you have already taken in a smaller triangle. If you see, you have already taken AC. This is already done. AD is done. Okay, sorry, AD is done. Okay, what is done, not done, is CD. Okay, so this is CD. Out of all of this, okay, when we started with Pythagoras theorem, which one do you think is required to you? Okay, so for that we will always try to see which are the common ones. Okay, very, very easy to find out. You can see this is AC, this is also AC, so we will not need this. Okay, so then we will continue and we will only write down what we need. So this one is not needed. You have to always see this common. Okay, AC and AC. So we'll write down the remaining. Then we have got BC by AC, and we have got AC by CD. Okay, so you'll cross multiply. AC into AC is AC square, and BC into CD. So this would be your equation number 1. What I want you to do now is, I want you to take two other triangles. Okay, I'll just name the triangles for you. I want you to take triangles ABC and triangle, the other triangle ADB, and I want you to prove similarity just like this, and I want you to write the proportional sides. I want you to eliminate one proportional side, and I want to see another equation with AB square in it. That is equation number 2. So that is what you'll solve and you'll send me.